Hello class, welcome to our online lecture in statistics and probability. So in this video, we're going to continue our discussion on how to perform estimation of parameters. So in the previous video, we learned how to find the point estimate of a population parameter. So specifically, the point estimate of the population mean, the point estimate of the population standard deviation, and the point estimate of the population variance. We also mentioned in our previous discussion that the point estimate of a population parameter will not always be equal to the population parameter. So for example, if we have our sample mean which estimates the population mean, we know that our sample mean will not always be equal to the population mean. So sometimes it can be equal to the population mean, sometimes our sample mean can be greater than the population mean, sometimes our sample mean can be less than the population mean, and vice versa. So sometimes our population mean, for example, sa asa na yon? So vice versa. So pwedeng our population parameters, for example, the population mean can be equal to, sometimes our population parameter can be greater than the sample mean, sometimes our population parameter of the mean can be less than our sample mean, or pwede ring using the mean of means if you have a multiple number of samples. So this is just for the population mean, just for example. So the point estimate will not always be equal to the population parameter. So in order for us to find the true value of the population parameter, we can use interval of values. So the mean, the sample mean, or maybe the mean of means, is the value that has the highest chance of being the population parameter. But there are also other values that could be the true value of the population parameter. So if we have our distribution here, and this is our sample, if this is our sample mean, or maybe our mean of means, so we know that the mean of means has the highest probability of being the population mean. But there are also other values of mean in this distribution that could be equal to the value, that could be the true value of our population mean. So what we want to know is which of the values can be the true, consider the true value, what intervals of values can be considered as the interval where the true value of the population mean can be found. So when we estimate using the interval of values, using ranges of values, it is called interval estimation. So in this video, we will learn how to perform interval estimation of parameters. But first, let us define what is interval estimation of parameters and what are the factors that factors affecting interval estimate or the confidence interval. So interval estimate is also known as confidence interval estimate or simply confidence interval. So it is a range of values within which the true value of parameter is believed to be found. So to represent interval estimate or confidence interval, we use the expression mu is greater than x bar minus e but less than x bar plus e, wherein x is the sample mean, e is the margin of error, and then mu is the population mean. So this means that the true value of the population mean, so the true value of the population mean can be found x bar minus the margin of error up to x bar plus the margin of error. So this is the interval of value. So let's say for example that our mean is equal to 2 and our margin of error is equal to 1.3, then the true value, we can say that the true value of our population mean in this example is that the true value of the population mean is equal to is 2 plus 1.3 up to minus rather 2 minus 1.3 up to 2 plus 1.3. So 2 minus 1.3 will give us 0.7, and then 2 plus 1.3 will give us 3.3. So therefore we can say that the true value of our population mean is from 0.7 to 3.3. So these are the ranges of values. These are the ranges of values where we believe the true value of the population mean can be found. So in this expression, we can already say that we can already say that our interval estimate is dependent on the value of our margin of error. So later on, we will learn how to find the value of our margin of error, and we will look into the different factors which affects our confidence interval. So this value here, the x minus e, is our lower limit or lower boundary, lower limit or boundary, lower boundary, and this value here is the upper limit, or also known as the upper boundary. So in order to solve for the lower limit, we need to subtract our sample mean by our margin of error, and to find the upper limit, we need to add our sample mean and our margin of error. So in determining interval estimates, a degree of confidence that the interval contains the true and fixed parameter is made. So therefore, we need to provide the value of the degree of confidence. So this degree of confidence is also known as the confidence level. So confidence level is one of the factors which affects the confidence interval. So again, confidence level is one of the factors which affects the confidence interval. So later on in the last part of this video, we will know how this confidence level affects the confidence interval. So the meaning of confidence level is that confidence level of an interval estimate of a parameter is the probability, that is the probability that the interval estimate contains the parameters. For example, if we say that we have 95, if our confidence level is 95%, then we are 95% sure that the interval estimate that we have, let's say for example, kung babalikan natin kanina yung 0.7 to 3.3, or if we express it in this manner, 0.7 to 3.3. So if we use this example and our value of confidence level is 95%, then we can say that there is a 95% probability that the true value of the population mean is found between 0.7, a mean sample mean of 0.7 up to a mean of 3.3. So within this boundary, within this interval, dyan natin mahahanap yung true value of our population mean with 95% confidence. So the confidence level describes what percentage of intervals, So it describes what percentage of intervals from many different samples contain the unknown population parameter. So for example, we have multiple samples, or if we have 10 samples with 100 sample size each, for example, and our confidence level is 95, then we can say that 95% of the time, so 95% of the time that the sample will contain our true population mean, or the true population parameter. So there are three commonly used confidence levels of interval estimates. So we have the 90% confidence level, 95% confidence level, and 99% confidence level. So therefore, if we have this level of if we have this confidence level, so we termed it as the 90% confidence interval, 95% confidence interval, and 99% confidence interval estimate. So these are just the most commonly used, three most commonly used confidence levels. So you can have more values, or more or other values of confidence levels. So among the three commonly used confidence levels, 95% level of confidence is mostly used by the researchers. Now, so let's talk about the confidence coefficients of the confidence level. So when we say confidence coefficient, or also known as the critical value, so it is a z-value that corresponds to the confidence level. So therefore, in order for us to find the confidence coefficient of our confidence level, we need to relate it, or to convert it into its corresponding z-value. So babalikan ngayon natin yung z-table natin. So to determine the critical value, or to determine our confidence coefficient, first we need to solve for the alpha value. Second, we divide the alpha value into half. And third, from the z-table, we look for the corresponding z-value of the alpha. So to have an example, so here, so for example, we would like to find the confidence coefficient for 95% confidence interval, or confidence level. So first, we need to turn this into its corresponding decimal point. So 95% is 0.95. To find the alpha is equal to 1 minus our confidence level. So therefore, we have here 1 minus 0.95. So this is our confidence level, 0.95. So 1 minus 0.95 will give us 0.05. So this 0.05, if we turn this into percentage, then our alpha level is equal to 5%. So 5% level of significance. So in maybe in your future pursuit in statistics, or if you have a statistics in your college, then you will learn about this alpha value. So the alpha value is the level of significance, 5% level of significance. So at 95% confidence level, our significance level is 5%. So therefore, so going back to our confidence coefficients, so we will use the value of the alpha in order to look for the corresponding z-value of the confidence level. So our second step is to divide our alpha value into half. So we have our alpha value is equal to 0.05. We need to divide it into half. So divide it into, to get the alpha value, the half of the alpha value is equal to 0.025. So we use half the value of alpha to find the critical value, or the confidence coefficient corresponding to our selected confidence level. So here I have the cumulative. So instead of the, so we have two z tables. One is the areas under the normal curve, which is half of the curve only. So from the mean to the positive area. Here, this one is the cumulative z table. So it is still the area under the normal curve, but this already includes the negative z values and the probability of the negative z values. So our alpha value, is equal to 0.0. Alpha value, half of the alpha value is equal to 0.025. So let's check. Okay, wait lang. Okay, so our half of the alpha value is equal to 0.025. So this 0.025 is the area under the normal curve. So we need to find the corresponding z value for this area in order to find the confidence coefficient. So using the cumulative z table, we need to look for the value 0.025. So here, so makikita natin na yung 0.025 is in this part. So 0.025. So the same with the normal curve concepts when looking for the z value given a percentage, given the percentile rank. So ang ginagawa natin, di ba, we will look for the value that is closest to the given value. So here we have 0.025. There is an exact value, but suppose there are two values closer to 0.025, then we need to get the average of their corresponding z value. So here, the corresponding z value for 0.025, so the z value for 0.025 is equal to negative 1.96. And since by applying the property of normal distribution, if we apply the property of normal distribution, the other half, the area corresponding to 0.025 is positive 1.96. So therefore, the z value or the confidence coefficient for 95%, or the critical value for the 95% confidence interval, is positive negative 1.96. So the confidence coefficient for 95% confidence interval is positive negative 1.96. So if we are going to write this in our normal distribution curve, this is how it will look like. So for 95% confidence interval, so this is the 0.025 area below the mean. This is our 0.025 area above the mean. So itong area na to, yung critical value natin is this line. So the 1.96 and negative 1.96, that is our critical value. So it is called critical value because it defines the region, the rejection and the acceptance region. So in your when you learned about hypothesis testing, you will understand what is the rejection and the acceptance region. So the critical value will tell us whether to reject or to accept our statement of hypothesis. So the 95% confidence interval is this region. Ayan. So this is our 95% confidence interval. So our margin of error, para makita nyo na kung nasaan dito ang margin of error, the margin of error is this region. This is our margin of error. This is our half of the alpha. This is also half of our alpha. So this is our margin of error. And this whole area here is our confidence interval, which is 0.95. So this is, if this is our mean, so x bar minus our margin of error will give us this value here. The lower boundary, x bar plus our margin of error, will give us the upper value, the upper boundary. So later on, we will learn how to solve for the margin of error. So here we have some practice problems in order to help us how to convert confidence interval into its corresponding confidence coefficient. So again, the discussion for this problem, practice problems, will be on Tuesday during our face-to-face discussion. So I will give you a copy of the cumulative Z table. So here are the common confidence coefficients. So given na siya, so for confidence level of 80%, we have 1.28. Confidence level of 90, we have 1.645, or simply 1.65. For 95%, we have 1.96. For 98, 2.33. 99, 2.58 Z value. 99.8%, we have 3.08, and 99.9%, we have 3.27. So out of this common confidence level and confidence coefficients, 95% is the most commonly used by the researchers. Okay. So now let's talk about the margin of error. So sabi natin, margin of error determines the lower boundary and the upper boundary. So it determines the lower lower limit and the upper limit of your confidence interval. So margin of error is defined as the maximum likely difference between the observed sample mean, so difference between the observed sample mean and your true value of the population mean. So it quantifies the amount of potential error or deviation between the sample estimate and the true population value. So to solve for the margin of error, we use the equation E is equal the critical value or the confidence coefficient times our standard error of means. So this equation is used when we are estimating parameters with known standard population standard deviation. So if we know the population standard deviation, then we can use this equation. So wherein our standard error is equivalent to the population standard deviation divided by the square root of our sample size. But if, for example, we do not know the value of the population standard deviation, then we can use the value of our sample standard deviation to get the standard error of means. So here, the critical value for this situation, the critical value is determined by our t statistics. So t of alpha divided by 2, here is z of alpha divided by 2. So later on in our next lessons, we are going to learn what is the difference between these two and how to perform interval, or how to find the interval estimate using this one and using this one. So for parameters with known standard population standard deviation, and for parameters with unknown population standard deviation. So this one, so the first equation of finding the margin of error, wherein we use this critical value z, and when we know the value of the so when we know the population standard deviation, so when we know the population standard deviation, and when the sample size n is greater than or equal to 30, we use this equation. So wherein this is our confidence coefficient and this is our standard error. And to compute for the standard error, we use our population standard deviation. And again, if we do not know the value of the population standard deviation, so we use the equation E is equal to T of alpha divided by 2 times the standard error. So this should be S, and S divided by the square root of n. So when the sample size, so we can use this when the sample size is less than 30, or we can also use this when the population standard deviation is unknown and then the sample size is greater than or equal to 30. So we will use the t statistics in these situations. So the t of alpha divided by 2 is the confidence coefficient, and then so this should be S, and then the standard error is solved. So the standard error of the distribution is solved using the equation S of x bar is equal to S divided by the square root of n. So instead of the population standard deviation. So we will have a separate discussion for interval estimation for known population standard deviation and interval estimation for unknown population standard deviation. So therefore, if in the expression, so if in our expression mean, a population mean is greater than x bar minus margin of error, or less than x bar minus margin of error. So if our margin of error is not given, we can expand the expression to this one. Ito, this is our margin of error for known population. This is for if our population standard deviation is known, or if this population standard deviation is unknown, we use this expression. So this one is the equation to solve for the margin of error. So as we can see in this expression, the margin of error is dependent on the value of the critical value or the confidence coefficient. It is also dependent on the value of our population standard deviation, and it is also dependent on the value of our sample size. So the same with this other expression, wherein it is dependent on the critical value or the confidence coefficient, the sample standard deviation, and the sample size. So these three, so this ito diba, itong confidence coefficient or critical value is based on a certain or based on a selected level of confidence. So therefore, we can say that the factors affecting confidence level or confidence interval or the interval estimate is our confidence level, the data variability as measured by the population standard deviation or the sample standard deviation, and the sample size n. So here in our graph, as we can see in our graph, if we have a higher level of confidence, the broader is our interval estimate. So therefore, kung mas mataas ang value ng ating level of confidence, for example 99, 90, 90, 99, 99.9, 95. So mas mataas din yung mas broad din yung interval ng values natin. So the lower the confidence level, the shorter or the narrower is our interval estimate. The same with the data variability. So the higher is the value of our standard deviation, the population standard deviation or the sample standard deviation. So the higher is their value, the broader is our interval estimate. And the lower is the value of our standard deviation, the narrower or the shorter is the value of our interval estimates. But for the sample size, if we increase the value of the sample size, if we have a large sample size, then the narrower or the shorter is our interval estimates. So the larger the confidence level, the broader is the confidence interval, and vice versa. The higher is the data variability, so S population standard deviation or the sample standard deviation, the broader is the confidence interval. And for the sample size, the higher is the sample size, the shorter is the confidence interval. So in our next lesson, we're going to learn how to perform to perform interval estimate of population mean when our population standard deviation is known, and another is we will learn how to perform interval estimation of population mean when our standard or population standard deviation is unknown. Okay, so that is for our face-to-face discussion this week.